Good morning, good afternoon, good evening, whatever it is that you're tuning in for the weekly recording for pre-algebra. We are in the week of October 6th, and this is also week 8. So when you're going to do your assignments this week, make sure you're looking for week 8 assignments. I do have a warm-up question that I would like us to start with to remind us about what we were doing last week. And you're also going to be doing a little project, a fun project this week that deals with parallel lines, transversals. Remember transversals, we got two sets of parallel lines. The transversal is what intersects those two lines, those parallel lines. And when they intersect the parallel lines, that transversal creates all different sets of angles. And there's lots of different angle pairs that have patterns that we learned about last week in Unit 2. So let's go ahead and start thinking about those angle pairs with this warm-up questions. If angle 4, so here's angle 4, let's go ahead and label angle 4. So if angle 4 is 150 degrees, what is the measurement of angle 5? So first I want you to identify what type of angle pair are angles 4 and 5. And then based on that angle pair and what we learned about that angle pair, we'll be able to then figure out what the measure of angle 5 is. So go ahead and try that question in your math notebook right now. If you need to, go ahead and click pause, and then when you're ready to check your work with mine, you can go ahead and click play. So angles 4 and 5, angle 4 and angle 5 are inside the two parallel lines. So we call that internal or interior. We call that interior. And then they are, here's our transversal. Oops, trying to highlight that. It scooted over a little bit. Our two angles are on alternate sides of the transversal. So we're going to call these, I'm going to abbreviate here, alternate interior angles. And what did we learn about alternate interior angles? We learned that they are always going to be congruent. They will always have that same angle measurement. Therefore, the measurement of angle 5 is also going to be 150 degrees. So we identified these as alternate interior angles, and thus it's going to also, that measurement of angle 5 will also have that same measurement of 150 degrees. Great. Alrighty, so this week you are going to do one more thing in Unit 2. And I mentioned this briefly on the previous slide. We're going to do a Unit 2 project where you're going to design your own city and town map. And what you're going to be doing is you're going to be designing your own roads. So you're going to have to make six parallel roads, the roads that run parallel to one another. And then, so I'm just kind of showing you briefly, then there would be grass between the roads, You're gonna have six roads, and then you're gonna have to also draw in two transversals to those roads. So you're going to have to do some transversals then. So roads that would come in and intersect those roads. And of course you would clean that up so it would look better. You could get rid of all the green grass and you'd have some roads. And then what you're going to have to do is place some buildings. And I give you specific directions as to where those buildings have to be. Like your house and a school might need to be alternate interior angles to one another. A park and a restaurant might need to be vertical angles. So that's what you're going to be doing for the Unit 2 project. You're going to design your own city and town map, and then you get to place some certain buildings in specific locations. And then you're going to move on to Unit 3, Session 1, and Unit 3, Session 2, and we're going to be learning all about transformations. So we're kind of switching gears a little bit and going into Unit 3. Alrighty, so let's do a quick review of the parallel lines, transversals, and angle pairs, since you are going to be doing a project where you need to place those buildings specific places that I mentioned. So the first thing we want to talk about is vertical angles. What do we know about vertical angles? They are congruent. So an example of a pair of vertical angles would be angles 2 and 3. So angle 2 and angle 3. And another set, there's all sorts, but I'm only going to give a couple examples. Angles 5 and angle 8. So remember, they share that vertex. They have to share that vertex, and they're always going to be congruent. So 1 and 4 and 5 and, or 1 and 4 as well as 6 and 7 would also be vertical angles. We also talked about, so there's more than just those examples, but for time's sake, I just want to get through some more of these. Let's talk about alternate interior. We just did that on the previous slide, so they have to be within or interior of the parallel lines. Alternate interior, and then they have to be alternating on different sides of that transversal. So these are also going to be congruent. And then some examples, I'm going to move up these examples. Some examples would be 3 and 4, which are labeled. And then there's only one other set, and that would have to be angles, I want to change colors here, 5 and 4. So 3 and whoops, that said 3 and 4. That should have been 3 and 6. I apologize. I don't know where I was looking there. 3 and 6 is one pair. 3 and 6 and 4 and 5 are the other set of alternate interior angles. So that's at 3 and 6. I apologize, I don't know why I put that as 4. So 3 and 6 alternating on different sides of the transversal and interior to the two parallel lines, as well as 4 and 5. And then we also talked about alternate exterior angles. So let's look at alternate exterior angles. And those are also going to be congruent with one another. So they will have the same angle measurement. They're going to be alternate on different sides of the transversal and then exterior to the parallel lines. So angle 1 and angle 8 is one set, as well as if we look at angles, what would that be? 2 and 7 would be our other set. Angle 2 and angle 7. So those are alternate exterior angles. And they have to be congruent. Corresponding, I think, is the one of our ones we have not talked about would be corresponding. So I'm going to erase all these colors so we can talk about corresponding now. Let's go ahead and do that in purple. Corresponding angles are angles that are located in the same position. So if we were to squeeze those two parallel lines together, they would be in the same position. So they're also going to be congruent. So angle 2, now imagine if we were to take lines A and M and squeeze those together. Angle 2 would overlap with angle 6. So those are congruent lines. Those are congruent lines. There's lots of different angle pairs here. I'm only going to do a couple. So we've got angles 4 and angle 8. And then we've got we've got angle 1 and 5 would be, and 3 and 7 would be. And then last but not least is same side interior angles, and these are the only angle pair that are not going to be congruent. So I'm going to go up here, I'm running out of room, same side angles. So same side interior angles. So let's go ahead and get rid of the angle pairs we have. Same side interior angles. There's only two pairs of these. Angle 4 and angle 6. They're both on the same side of the transversal, and they're both interior. So those would be a set of same side interior angles 4 and 6. And then the other pair would be on the other side of that transversal, 3 and 5. And these ones are going to be supplementary. Same side interior angles are really the only ones that are not congruent. They're going to be supplementary, which remember, supplementary, it means they add up to 180 degrees. So make sure that you've got this down so that when you go to do the Unit 2 project that you're placing your buildings in the correct places. All right. I'm going to go to the next slide, so if you need to click pause to take some good notes on this slide, which I really recommend you do, so that when you go to do the Unit 2 project and design your own city, you're getting full points for placing your buildings in the correct positions. Alrighty, so this week we're going to focus on transformations. So transformations is when we take an object and we move it somehow. So we can either rotate an object, we can either translate it, where we're just simply taking an object and sliding it. We're taking an object and sliding it. Rotating it, we're moving it in a circular motion. Dilation is either when we enlarge or shrink an object. And then last but not least, we're going to talk about reflections, where it's a mirror image that we see. So before we do that, let's review these different terms, congruent versus similar. And I don't know if nope. Okay, so congruent versus similar. So congruent is when we have the exact same, I know the one's placed a little bit higher than the other, so let me try to line those up so they look. Congruent is when we have the same shape, and not only do we have the same shape, but they have to be the same exact size. So when we talk about congruent, we're talking about the same shape and the same size. Versus similar, those are both squares, so they're the same shape, but now we've got a different size. So when we talk about similar, we're talking about the same shape, but different size. So different size. So that's the big difference between congruent and similar. Congruent is the exact same. It's going to be same shape, same size. Similar is going to be same shape, but can be different sizes. And we're going to talk about our translations and how most of them are going to keep the same shape and same size. So when we reflect, rotate, or translate, we're going to keep the same shape as well as the same size. So all these are different, they're going to be congruent. They would be congruent. Whereas a dilation, that's kind of our oddball here, is the dilation is going to it's when an object gets bigger or smaller. So we're going to have the same shape, but different size. And we'll see that. Keep that in mind, those terms similar and congruent as we're looking at these different types of transformations. So something to note here, transformations. Transformations includes all these different things here. A transformation can be a reflection, it can be a rotation, it can be a translation, or a dilation. So I know that translation and transformation sound very familiar. Note the difference there. Transformation versus translation. So a translation is a type of transformation. Just like if we were talking about cars, we could talk specifically about different kinds of cars. We've got Jeeps, we've got Subarus, we've got Corvettes. So those are all different types of cars. And that's the same thing here. Rotations, reflections, translations, dilations are all different types of transformations. Alrighty, so some important vocab you're going to see this week and some notation that I really want you to watch out for as you're learning about those transformations this week is pre-image and image. So in all of those types of transformations, I talked about how there's some type of movement. Either it's rotational, you're just taking an object and sliding it, you're reflecting it, that mirror image, or you're making it bigger or smaller. So you're always going to start with a before image, before the transformation has taken place. And that before, that prior to the transformation, that before, is going to be your pre-image. So think of your pre-image as before. So think of your pre-image as before any type of transformation. And then the image is going to be the figure after the transformation. So after the transformation is the image. So before, pre-image, after is the image. So we need to note, and we had to come up with a certain way to let readers know what was the pre-image and what was the image. So what was the before and what was the after. So we came up with a way of writing our points to let the reader know what is the pre-image and what is the image. So if you look really close here, this is the pre-image. This triangle right here is the pre-image. It hasn't been moved yet. It hasn't undergone any type of transformation yet. Look at the points. So we would call this triangle A, B, C, but look at the points. They're just normally written, right? Nothing special about them, just the normal letters. Then look at the image. So here's our image, and look at what we have. We've got these little ticks. We call them primes. We've got primes, which is apostrophe, next to the points. That is how that's how we write the points to let readers know that that is the image. So the image is always going to have these little primes or apostrophes next to them. And that's how we know that that's the image. So we need to know which one's the image and which one is a pre-image so that we know what type of movement took place. So it's important that we know the pre-image and the image and can tell them apart. So right here, translation mapping. So first I want you to focus up here. And can you tell me which triangle is the pre-image and which is the image? So look close there next to those letters. So remember, the pre-image won't have any apostrophes. So this one's going to be the pre-image. It just happens to be on the left. And this one on the right, we see that there's those little ticks next to the letters. So that's going to be the image. And one last thing I'm going to go over with you is translation mapping today, and then I'm going to let you learn about the other transformations on your own as you go through the lessons this week. So translations is simply when you take an object and you move it. So you move it vertically and horizontally. So you can take an object and move it to the right, you can move it to the left, and you can move it up and down. And when you combine those, you get vertical and horizontal movement. So let's look at this object. So let's highlight point A here, and then point A with the apostrophe or the prime that lets us know it's the image. So we know it's moving to the right. We know it's going from here to here because we identified which was the pre-image and which was the image. So how many units does this point move to the right? So to get from our pre-image A to our image A, we're going 1, 2, 3, 4 units to the right. And be specific when you tell me directions. Don't tell me over. Over is not a direction. I hear this all the time. It is not a direction. So never use over when you're talking about movements and translations. And then how many units are we going down to get to that A? We're just going down 1 unit down. So that is how we explain the triangle, how it moved from the pre-image to the image. We explained it right here. 4 units to the right and 1 unit down. Now there's a special way to show that movement, and that's called translation mapping. And what it looks like is, remember the X and your Y coordinate? So remember your X coordinate always tells you the horizontal movement. Right here, the X always tells you horizontal and the Y always tells you the vertical movement. So to show translation mapping, we've got this special way of writing it. So the first thing we always start with is writing X and Y, just like I just did. And then I'm going to put x plus 4 to show it moved 4 units to the right, and then I'm going to write y minus 1 to show it moved down 1 movement. So notice that there's a plus sign between the x and the 4 to show right. If I were going to the left, I would use minus, a negative sign. And then here I showed a negative sign to go down, just like in the opposite. If we wanted to show we were going up, we would use an addition sign. But this is translation mapping, and you're going to learn more about this week when you go through your lessons, but I just wanted to give you a preview of what it looks like. So you always start with writing the parentheses x and y, just as is. You write an arrow, and then you show your horizontal and vertical movement. I'm going to go to the next slide where we're going to take a look at an example, one more, and then we're going to be done. So here I want you now to explain the movement. So I'm giving you the translation mapping notation, and I want you to tell me how it moves, how the object would be moving. So again, you always start with your x and your y, the arrow, and now we've got x minus 2 and x plus 5. So we've got a minus 2 now. So what direction are we moving in? So if plus was right, that would mean the minus is telling us we're going left. So we would be going left 2 units. And then what is that y plus 5? So it's minus was down, so what do you think plus is going to tell us? To go up, good. And that means we're going up 5 units. So each point would move left 2 units and up 2 units. So just remember, horizontal movement is always attached to the x coordinate, and vertical is always attached to the y coordinate. And that's a wrap. So time for the key phrase assignment, and I want you to tell me, how can you tell the pre-image from the image? So we talked today about how it was important to come up with a way that somebody looking at 2 figures could tell which one is the pre-image and which one is the image. And how can you tell the pre-image from the image? So go ahead and make sure you enter that in for the week of 10/6, October 6th, and that's a wrap. So have a wonderful week, and let me know if you have any questions as you're working this week.